Hello students, welcome back. Today we are back with a new chapter AC current. Okay, before moving towards AC current, let us understand what is direct current and what is AC current. There are generally two types of current. One is AC current, that is alternating current, and one is DC current, and that is direct current. Okay, so what is a direct current? Direct current, you can also say it is a unidirectional current. Unidirectional current. What does unidirection means? It moves only in one direction. Unit means one and direction means the direction in which it moves. So direct current can also be known as unidirectional current, means the current which moves only in one direction. It may change its magnitude or it may not change its magnitude, but it moves only in one direction. Let us take example. Okay, suppose this is current. It moves only in one direction. It moves only in one direction. So what is the value over here? It remains constant. Suppose it keeps on varying. Okay. Suppose the variation starts. It may vary only in positive direction. Here it is varying, but it is only in positive direction. We can show the negative direction in the downward direction. Okay. Suppose it is not necessary that it is always in positive direction also. It may be in negative direction also. It may be this way also. But what does it do? It never changes its direction. If it is negative, it always remains negative. If it is positive, it always remains positive. Okay. And here one more thing we had seen, that is it remains constant, or it may vary. It may vary or it may remain constant, but it will not change its direction. This is the main condition. It remains unidirectional. It never changes its direction. Okay. Whereas now if we compare to AC current, what happens? If we compare it to AC current, it will change its direction. Okay. After every cycle, once it will be positive, then it will be negative, then again it will be positive. Okay. It may have constant magnitude, but then also it may change the value. It may change the direction. Suppose it is like this. Here you can say the magnitude. Here suppose let us say 2 ampere. Here also let us say minus 2 ampere. So the magnitude remains the same, that is 2, but the direction keeps on changing. The magnitude remains constant, but the direction changes. Here direction also changes and magnitude also changes. If we draw another graph, let me take it over here. We may draw it like this also. Okay. Alternating current always changes its direction. Once it will be positive, then it will be negative, again positive, and continuously it will change the direction. Okay. I hope this much is very clear to you. You can very fast copy it. You can pause the video and copy it. Okay. I will rub this. Okay, now we will be studying three important quantities: amplitude, time period and frequency. Amplitude, time period and frequency. Okay, before that let me write down what is the formula for alternating current and alternating EMF. EMF was E equals to E0 sine omega t, whereas for current it was I equals to I0 sine omega t. Okay, it was this. Yes, correct. We have studied this in AC generator and before that also. Okay. So now over here, what is amplitude, what is time period and what is frequency. Okay, I'll rub this extra cycle also. Just because we want to understand the concept, I am rubbing out the extra cycle. We'll just complete only one cycle so that it is easy to understand. Okay. So first thing is amplitude. Amplitude means the highest value in either direction. It may be positive, it may be negative, but the highest value is known as amplitude. Means here the amplitude will be this. This will give you the amplitude. Or you can say this will give you the amplitude. This becomes the amplitude of the system. Okay. What will be value of this amplitude current? Here you can see I is equals to I0 sine omega t. Okay, what is the range of values of sine? Sine will always vary from -1 to 1. it cannot be greater than 1. If you put any value of omega t over here, it can never be greater than 1. So the highest value of sine will be 1, which means that the highest value of I will be equals to I0. So this value will be I0. Okay. Similarly here also it will be I0 in negative direction. Okay. So this shows the amplitude. Once again I will repeat what is amplitude. The highest value of the current or EMF. You can say anything. If there is any quantity in this form, sinusoidal form, you can take any quantity. But here we are talking about current, that's why I am speaking current. Amplitude is the highest value of the current in either direction. Highest value of current in either direction. Okay. I hope this is very clear to you. This is known as your amplitude. Amplitude. Okay. Now, second is time period. What is a time period? Time period is time taken by the current to complete one complete cycle. Time taken to complete one complete cycle. Okay. It started from over here. It completed, reached the same point over here. Once it went to positive, once it went to negative, and from here again it will continue the same cycle. Okay. So it completes the cycle between these 2 points. It completes the cycle between these 2 points. Okay. What is the traveling that it has done? It will complete the cycle in one whole 360-degree rotation. We were turning the axle in AC generator. When the coil completes 360-degree rotation or one complete cycle, at that time this cycle will get completed. Okay. So time period will be the time taken by the current to complete one full cycle is known as your time period. Okay. What will be the time period? Time, we'll write it in this manner. Velocity, omega is equals to distance upon time. Okay. Omega is angular velocity here because we are always talking in angular velocity. We are not going linear. So it will be angular velocity is equals to d upon t, that is distance upon time. What is the distance? 360 traveling we are doing. We are traveling 360 degree, which means that it can be written as 2 pi. 0, pi by 2, 2 pi by 3 and 2 pi. Okay. Sorry, 3 pi by 2. So we are covering 360 degree and it can be written as 2 pi. So here I can write down 2 pi upon t is equals to omega. Now what we are asking? We are asking time period. So what will be the time period t? T is equals to 2 pi upon omega. Okay. 2 pi upon omega, that will be our time period. Okay, I hope this is very clear to you. What is time period? Time period is time taken to complete one complete cycle or one full cycle by current. Okay, that is T is equals to 2 pi upon omega. And last one, frequency. What is frequency? Frequency is the amount of cycles completed in unit time, or you can say amount of cycles completed in 1 second. Okay. So if we are given some particular time, then what is the amount of cycles completed in single unit time? Okay. So that will be equal to F. F will be equals to 1 upon T. F will be equal to 1 upon T. Number of cycles completed in unit time. Okay. If we divide anything with that particular quantity, we get that particular quantity in unit time. Okay. So it can be written as 1 upon 2 pi upon omega, which can be written as omega upon 2 pi. Okay. This we might be using somewhere in our chapter later on. But these are the concepts. Main thing, amplitude, the highest value of current in either direction. Time period, the time taken to complete one full cycle, that is to complete 360 degree, which is given by T is equals to 2 pi upon omega. Frequency, amount of cycles completed in 1 second, or you can say in unit time, is given by F is equals to 1 upon T, which is equals to omega upon 2 pi. Okay. Students, I hope these concepts are very clear to you. So keep studying. All the best. Thank you.